Hello and welcome to Higher Maths Differentiation. First of all, why do we differentiate? Well, in higher maths, the majority of the time, the reason why we differentiate is to find the gradient of a curve at a given point. So here we have a curve. If we drew a tangent to the curve at A there, the gradient would be different to the gradient of the curve at point B. Obviously, at point B, that curve is steeper than it is at point A. The process of differentiation would enable us to very, very quickly find the gradient of the curve at point A and also the gradient of the curve at point B if we needed it. Using our National 5 knowledge, what we would need to do is very, very, very accurately sketch this curve. We would then need to draw a tangent to the curve at point A. We need to pick 2 points here and here, and then we'd need to draw a straight line in, and then we would need to find the gradient of that line. So that process would be riddled with error because we might not sketch the curve as accurately as possible. It would also take us quite a long time. But using the process of differentiation, we're able to do that quite efficiently and 100% accurately. So so that was first of all. So second of all, how does differentiation work? Well, if you're interested in this, we're not going to be tested on how differentiation works. But if you're really interested, have a look at Calculus Derivatives 1, Taking Derivatives, Differential Calculus from Khan Academy on YouTube, okay? So Salman Khan, who is absolutely excellent, goes through the process of differentiation from first principles. And it's only a 10-minute video, so have a look at it if you're interested. But as it says down here, an expression is called a derivative. So once we've differentiated, we get the derivative. And the process of finding this is called differentiation. It is possible to use this definition directly to find derivatives, but you will not be expected to do this. Instead, we will learn rules which allow us to quickly find derivatives for certain curves. Okay, so this is differentiation from first principles. We don't need to know how to do this. If you want to have a look at, as I said, at Khan Academy's video on this, it really is excellent. Have a look at it. Find out the process behind it, but you'll not be examined on this. And you don't really need to know how it works. You just need to know how to use it and to apply it to find the gradient of a curve at a given point. So let's have a look at the basic rule for differentiation. So if we have f of x equals x to the n, so we might have f of x equals x cubed. And we're going to differentiate with respect to x, so that means we're going to differentiate the x terms. What we would do, we'd bring the power to the front and then drop the power by 1. So if we had f of x equals x cubed, we bring the 3 to the front and reduce the power 3 by 1, so we'd end up with 3x squared. And the notation we would use would be f of x equals x to the n for our starting point, and then once we've differentiated, we would use f dashed of x equals nx to the n minus 1, or if f of x equals x cubed, f dashed of x equals 3x squared. So stated simply, the power n multiplies to the front of the x term, and the power lowers by 1, which is where that n minus 1 comes from.